across two plants that both have round seeds and are heterozygous. What is the probability of all possible phenotypes and genotypes of their offspring? So we are crossing two plants that are heterozygous. Remember, heterozygous means that they're different. So we will have one capital and one lowercase allele. And it does not tell us which is male and which is female. And so it doesn't matter which side of the square you write that information on. So, but both parents are the same. So for both parents, we're going to put a capital R and a lowercase r there. And then for the other one, we're going to put a capital R and a lowercase r there. All right, so our next step is to distribute the alleles. So we're going to look at the top left box. On the top left box, we see a capital R above it and a capital R to the left. So we're going to fill it like that. In the top right box, we see a lowercase r above it and a capital R to the left. Okay, notice I'm always putting the capital first when it's heterozygous. In the lower left box, we see a capital R above it and a lowercase r to the left. And then finally, the bottom right, we see a lowercase r above it and a lowercase r to the left. So those are all our possible genotypes. We need to figure out the probability of each. All right, so all right, so I just realized I had a mistake on the slides. All right, so I just realized that I had a mistake on this slide. So I am going to fix that real quick. I'm going to change this. All right, so through the magic of video, they are magically changed. I paused the video, but let's go through this now. So we're going to look at how many boxes have capital R, capital R. And I see the top left box has that, so no other one has it. So it is a 1 in 4 probability. I'm going to count how many boxes have capital R, lowercase r. I see that there are 2, the top right and bottom left. So the probability is 2 out of 4. And then how many boxes have lowercase r on the bottom right? There's 1. So the probability is 1 out of 4. Okay. And so now I need to do the possibility of the phenotypes. So the offspring can either be round or wrinkled, or have round or wrinkled seeds. And so in order to have round seeds, I need to have one or more dominant alleles in their genotype. So I see that in the top 2 boxes and the bottom left boxes, those all have at least 1 or 2 capital R. So there's 3 boxes that have that phenotype. So that would be 3 out of 4. And for wrinkle, that you need to have 2 recessive alleles. There's only 1 box, but that which is the bottom right. So there is a 1 out of 4 probability that it is wrinkled.